Let us talk about the process control block, which is also called as PCB. There are several processes which are going to compete for resources or for CPU utilization. While processes are said to be in different states while they are being created, like if it is in the new state, it is just being created. If it is in the ready state, it is waiting for execution. Once it is in the running state, that means it is executing the instructions. If it is terminated, that means the process has completed its execution. So for the operating system, it needs to know in what state these different processes are executing or remaining at a particular given point of time. Now, in order to ensure information about each process, the OS must have data structure representing the process and its database or the state in which the process is executing. The PCB or the process control block contains all the information about a process. PCB is where the operating system keeps record of the process's hardware execution state, that is program counter, SP, register, when the process is not running. Looking at the structure of the PCB, first is the process ID. This is utilized or used to know or identify a particular process. Then the state is the information about which state the process is currently being in. Pointer points to the particular information or it points to the resources which are required. Priority is set to each process based upon different algorithms. That information is held in the priority section of the PCB. Program counter points to the next instruction that has to be executed. CPU registers utilized by the PCB is collected as information in the CPU registration or CPU register block. All the input-output information related to a particular process is also stored in the PCB. Accounting information and other information forms the last element of the PCB control block. Operations of a PCB. When a process is running its program counter, stack pointer, that is SP, registers, all of them are loaded on the CPU. That is, the processor hardware registers contains the current values of these elements. When the operating system stops running a process, it saves the current values of those registers in the PCB for that process. When the operating system is ready to start executing a new process, it loads the hardware register from the value stored in the process's PCB. The process of switching the CPU from one process to another is called as context switching. So if a process is waiting for an input-output operation to happen, then the CPU allocation may take place to another process which is in the ready queue. So allocation of CPU from one process to another process is called as context switching. Time sharing systems may do hundreds or thousands of context switching in a given second. That is about PCB and operations of PCB. Thank you.